Hello, everybody. The next section we're going to do is 9.6. So 9.6 has the name of the section is exponential and logarithmic equations. So I'm going to make two videos on this one. So this is the first one. Video one is solving exponential equations, and we have two types of exponential equations. The first one is requiring no logarithms, and the second one is requiring logarithms. So now I'm going to focus on first one first, requiring no logarithms. Mean we're going to use here the principle of exponential equality. So this one is when b to the power m equals b to the power n. Well, then remember m is always equal n. So the saying is that if you can come up with the same base, we can always equate the powers. So for example here somebody says solve this. So exponential equation means the variable going to be on the top. So let's say this one here. Well, first thing the easiest way is using the principle of exponential equality. So look, we can write this one 4 to the power 2x, and we know the 16 is the same as 4 squared. So look, the base is the same. So now that's the first thing. Look, if you cannot come up with the same base, then that's the other way is using the logarithms. So now if the bases are equal, well then the powers are always the same. Well then 2 divided by 2 gives 1. So that's the solution. So now you can see, we could check x is 1, where the 2 times 1 is 2, 4 squared is 16. So you can always check. In this case, you should be able to tell what the answer is going to look like. Okay, so let me show you a couple of more examples. Here is one. So remember, the first one we try to focus is where we can use the principle of exponential equality. Here is for example, we can make up one example here. So let's say somebody says 4 to the power 3x plus 1 equals 16, or we can just write here 8, for example. So somebody asks you to solve this one. 4 to the power 3x plus 1 equals 8. So now the first thing look is come up with the same base. So now here 4 to the power 1 is 4, 4 to the power 2 is 16. So 4 base not gonna work. How about base 2? So we know the 4 is 2 squared, 8 is 2 to the third power, so base 2 will work. So think about base 2. Look, 2 squared is 4, where the outside power is 3x plus 1. And then this one is the base 2, so that's problem solved. And if you remember the exponent rule, so when there's a power over the power, you multiply. So make sure there's a binomial, so we multiply the powers. So this one is, what's 2 times 3 is 6x, and what's 2 times 1 is 2. So you multiply the power, meaning you're going to multiply 2 times 3x plus 1. 3x plus 1 must be inside the parentheses. We will distribute. Well, then this one is 2 to the power. Look, so that's the principle of exponential equality. So the base is the same. Well, then what is the first power? 6x plus 2. What is the second power? 3. So now you just move and divide. So positive 2, other side become minus 2. So 6x equals 1, x equals 1 over 6. That's the answer. Okay, so that's the first part when no logarithm is required. So now, if you cannot come up with the same base, you must take logarithm both sides. And we also know log has base 10 and ln has base e. So now, if there is the e, then we take ln. Everything else we can just use log. So here is objective B as solving exponential equations requiring logarithms. Okay, so now example from your textbook. So here, solve 7 to the power x minus 2 equals 60. Okay, so now let's look, 7 is the base. There's nothing you can do to make a base 7 here to get a 60. So this one would get take, so when we take, so we're going to use this power here. If you remember, log m to the power n is always log n log m. That's your the power rule if you look your last video, so the laws of logarithms. So now here's the base is 7, so in this case we're going to take log both sides. Okay, so here is the log of 7 to the power x minus 2. So here is the log of 60. Okay, so that's the one is the requiring logarithms. So now log of m to the power n is always what? The power always multiply in the front. So is the x minus 2 log 7 equals log 60. So now we must isolate x minus 2 first. So then we're gonna divide both sides by what? Log, so log 7. Well, then x minus 2 is log 60 over log 7. Well, then what is the opposite of negative 2 is positive 2. So now when you use your logarithms, so here, let's see what I do here. So when you just use the calculator here, go log 60 divided by log 7, and whatever the answer is, add 2. So this is approximately is, he's keeping the 4th place value, so 4.1041. That's the answer. So go to the calculator. So make sure to do log 60 over log 7 first, and whatever the answer is plus 2, so then it's approximately 4.1041, and he is keeping the 4th place value after decimal. Okay, so let me maybe show you one more example from the textbook. When the base is e, or I can show you more than that. So here is a the number 18 from your textbook. The page is the 631, 9.6. So it's to solve 5 to the power x plus 2 equals 15. Okay, so now again, look, 5, well then 5 to the power 1 is 5, 5 to the power 2 is 25. So you cannot use the principle of exponential equality. So then we're gonna take log both sides. And remember, one more time, log of m to the power n is always n log m. So here we're gonna take log both sides. X plus 2 is very similar to last problem. Okay, so now log of m to the power n, so it's going to be x plus 2, use the parentheses, is binomial, log of 5 equals log 15. Well then make sure you isolate x plus 2 first, so divide both sides by log 5, so x plus 2 is log 15, log 15 over log 5, and make x by itself, so opposite. Well then when you calculate, just like last one, so we're keeping the 4th place values, so use the calculator, go log 15 divided by log 5 and minus 2 both sides. So let me show you actually, this time I don't have answer in the textbook. So here is the log 15 divided by log 5 equals. Well, then what the answer is? Minus 2. So your answer is approximately negative 0.3174. We are keeping the 4 place value, so we are rounding to the nearest 10,000. So okay, that is your first objective. Let me show you one example when the base is e. So then remember, if the base is e, then we'll take ln, not log, because ln and e, they always cancel. Okay, so here's one. For example, number 20. Number 20 is e to the power t equals 20. So it's a solve. We're going to solve for what? The variables, which is t. So now, in this case, this is the rule we're going to use. So first of all, we're saying is ln e, the power x. Well, then the base is always e, so then the answer is always x. So ln as the base e, they always cancel out. The answer is always the x. So in this case, we want to cancel the base e. We'll then take ln both sides. Ln both sides. So then look here. Ln e to the power t equals ln of 20. So then we also know ln has the same as ln base e. That's the natural log. Well, then the rule is when ln has the same base as the value, so this is always t. Well, then t equals ln of 20. If you say leave as is as the exact value, that's the answer. But we can also use the calculator. So t is approximately ln 20. So just click on ln 20 and equal. So this is approximately 2.9957. That's the answer, approximately. Okay, so this one is your objective. The first one, solving exponential equations. Watch very carefully. And for the logarithmic equation, I'm going to make another video because the rules are different. So keep in mind, there's two types of logarithmic exponential equations. The first one is we do not need any log. And the second one is we do need a log. Thank you. And we'll see you soon for the second video for 9.6, which is logarithmic equations. Thanks.